Today we will be factoring out a common factor, and there's two parts to this lesson. First part is factoring out a monomial, and so remember the word monomial has the word mono in there, which just means one term. And so this term can't have negative exponents, so it can't be dividing by can't be dividing by variables, and can't have negative exponents on a variable. Well, what we'll do is we'll take a look at each of the terms separately. So let's look at the first one right here. We have 36a squared, and over here we have 24a. So what do these two have in common? Well, they both have an a. This one has two a's, this one only has one. So all we can pull out is one a. Can't pull any others out, because if I pulled out two a's here, I would have an a left on the bottom of the fraction. So just one a I can take out. Now let's take a look at the numbers 36 and 24. What goes into both 36 and 24? Well, you might say 6 to start off with, but there's a bigger number. And so the biggest number is what you're looking for, and that is 12. 12 goes into 36 3 times. 12 goes into 24 2 times. So what you're going to do is take the number that you have right here that you've divided by, and that number goes outside the parentheses. And then you can either do one of two things. You think of 12 times what makes 36? Well, that's 3. 12 times 3 makes 36. Or you divide 36 divided by 12. Well, that makes 3. Well, how many a's are left over? Well, a times a makes a squared. So that would match this. Or you could just take out this a from this 1a here, and you're left just with 1a left over. You see 12 goes in that 36 3 times. So we have 3a. That's what we have right here. That's what goes inside the parentheses here. Well, on this one, you can do the same thing. 12 times what makes 24? Well, that'd be 2. So you could put 2 there. And the a's cancel out. So 12a times 2 makes 24a. You see how these a's are canceling out? 12 goes into 24 2 times. So there it is. 12a multiplied by the sum of 3a plus 2. And if you multiplied back out, you'd get right back to the same problem. So that's what we're doing. We're taking a look at each of the terms. So I draw a line under each of the terms, and look how many variables you can remove. Well, here we can take out 2 x's. So let's do that. Here we could also take out 2 x's. No more x's can be taken out because this one has 3, but this one only has 2. So you can only take out the smallest number from one of the terms. So x squared is the smallest number of x's in this second term. Well, what do 10 and 15 have in common? What can you divide them by? Well, that number's 5. And so let's take out that 5x squared. We're going to put that on the outside of a parenthesis. 5x squared. And then think about what goes inside the parentheses. So you can do one of two things again. You can either divide like this. X squared goes into 3x's one time, so there's x left over there. How many numbers are left over? Well, 5 goes into 10 2 times, so you divide by 5, and that leaves you with 2, so 2x, and you can multiply back out. 5 times 2 makes 10, x squared times x makes x to the third, so it does end up matching. Same thing over here, so these x's will cancel out these 2 x's, so no more x's to write down, just a number. 5 goes into 15 3 times. There's your number, minus 3. And you can multiply back out. 5 times negative 3 makes negative 15. And then x squared is left over, so negative 15x squared. So it matches. Well, we've got another problem here. This one has 3 terms. So you just got to draw 3 sets of parentheses. Looking at the x's first, all we can take out is 1x. Same thing here. They all have to have the same number that you're taking out. So I'm taking out 1x. Now what goes into all these numbers? Well, hopefully you saw 7 goes into all those numbers. So that's all we can do is just take out a common factor of 7x. So 7x is the number that you're going to put on the outside of the parenthesis. Draw a big set of parentheses this time because you need to fit 3 numbers inside. Let's see what's left over. Well, this x is going to cancel out 1x here, so we're left with 2. 7 goes into 14 2 times. So there it is, 2x squared. If you multiply back out, 7 times 2 makes 14. X times x squared makes x to the third. Next one here, x cancels out one of the x's here, so you're just left with 1x left over. And 7 goes into 63 9 times. So 9x is what we have for the next term there. And 9x times 7x makes 63x squared. Last one here. X cancels out this x. 7 goes into 7. So we're left with 1 left over. So minus 1. This is the common mistake. People forget this term or think it's supposed to be 0. But it's not. You see, 7x times by negative 1 makes negative 7x. So you should be able to multiply back out after you're done and see if it matches the original problem. A few more to practice here. Let's take a look at this one. We've got a 4g to the 4th power, negative 2g to the 3rd, 3g. Well, what's in common? Only 1g to start with. 1g because this one only has 1. And then looking at the numbers, 4, 2. Well, so far 2 is the common factor, but then we have an odd number of 3. So 3, 2, 4 have no common factors but 1. So that's all you're taking out, just a 1g this time. So we just stick g on the outside of a parenthesis. Again, large parenthesis, allow room for everything for those 3 terms. Let's see what's left over. G goes into these 4g's. We have 3 times. So we're left with 4g to the 3rd power. And the next one, we have this g going into one of the g's here, leaving us with 2 g's left. Can't cancel out the number, because there's no common factor but 1. So we have a minus 2g squared. Alright, well this g cancels out this g, so you're just left with 3. And there's our answer, right there. Well, taking a look at the next one, this one's a little bit different because it's not in order. So I'd like you to put these in what I call a descending order. Descending order goes in from the highest exponent to the lowest exponent on the variable. So descending order, this x squared term, this is the first one, and then the x, and then this term needs to go last. So I'm going to put it all the way back here, and I should only circle the sign that's in front, not the sign behind. So I'm going to erase that part just so we don't get that confused. So just erase this little part right here. So looking at just that 3, it just so happens to be a positive 3, which is good. And so we're going to rewrite the problem. I'm going to rewrite this as 9x squared plus 6x plus 3. So I want you to get in the habit of writing the terms in descending order. Let's take a look at the common factor here between these numbers. No x's are in common. You can't take out any x's, only a number, and that number is 3. So you're going to pull that 3 on the outside of a parenthesis and do some reducing, see what's left over. So we go ahead and do that. We have this 3 goes into 9 3 times, so 3x squared. 3 goes into 6 2 times, so 3 times by 2x. Gives me a 6x. I'm sorry here, let's see here. 3 goes into 6 just 2 times, so we're left just with that 2. So 2x. And then this 3 here cancels out this 3, so we're just left with 1. And so that's the big thing that we have is just that 2x here and the 1 here. That's the big number that most people forget, is that it's just 1 left over when everything cancels. We're only left with 1. So 3 times 3x squared makes that 9x squared, which we had here. And then the 3 times the negative 2. Oh, got a sign error here. You see, when I multiplied back out, I checked my answer, and we made an error. Let's see if we can find it. Here I've got 9x squared. Here I've got negative 6x. And 3 times 1 makes a positive 3. Does this match my original problem? No. What's wrong? Right here. Let's circle the error. So it's right here. This number, this should be a positive 6. So what do I need to change? Well, right here, 3 times by this negative 2x needs to be a positive 2x. So let's go back and check our answer now. 3 times 3x squared makes the 9x squared. 3 times 2x makes the 6x. And 3 times 1 makes 3. So that does match. So let's go ahead and rewrite our answer. So again, as you can see, I made an error. Well, that's not uncommon. It's typical to make errors. So it's good to go back and check your answer as you're going. And so to make sure that we don't make the final problem an error, we can check our answer as we go to see if we're getting the right answer. Well, there's another chance to redeem ourselves. We can look at putting it in descending order. Let's take this positive 11, move it to the other side. Let's see what's left over here. So we're moving that because I want it in that descending order. So I got the 33a squared, then the minus 22a, then the plus 11. And so as I look at this, I want to factor out a common factor. What goes into all these numbers? Well, I see the numbers repeat, like 3, 3, 2, 2, 1, 1. So that tells me 11 goes into each of these numbers. But I can't pull anything else out because this 11 doesn't have an a term. So 11 is the only number we can take out. So we're going to take that 11, put it on the outside of a parenthesis. Remember, this goes on the outside. And then we do some reducing. So let's see what can cancel. So here we have this 11 goes into 33 3 times. So here's what we have, 3a squared. 11 goes into 22 2 times, so what do we have here? Negative 2a. So I didn't make the mistake this time. And 11 goes into that 11 1 time. So make sure you put that plus 1. Check. Let's check and make sure it makes sense. 11 times 3a squared makes 33a squared. 11 times negative 2a makes the negative 22a. 11 times 1 makes 11. See, now you know you have the right answers. Well, the next part is going to be talking about factoring out a common binomial. So check that one out.